wanted to say good morning, good afternoon, and good evening to some of you out there. I'm not sure what everybody's time zone is, but my name is Shawn Sills, and I'm one of the cloud solution architects at Logicworks. And we're just going to basically have an informational kickoff session to kind of present how to build cloud native architectures in Azure and AWS. So, the agenda today will be discussions around different types of cloud native solutions, differences between microservices, serverless, and containers, some benefits and challenges, and basically how Logicworks can help get you there. So a little bit about myself and a little bit about Logicworks. And if you don't know what Logicworks does, and it's a little bit brief what Ron discussed, we essentially are a leader in cloud migrations and managed services support. We also offer consultative professional services for project-based work. And we're a leader in Gartner for public cloud professional and managed services worldwide. Under our platforms, we manage about trillions of dollars in financial transactions, and they're performed on our platforms every year. And we have millions of HIPAA compliant medical records under our management too as well. Logicworks is a premier partner of AWS, but we're also a gold partner, Azure Expert MSP. And some of our accreditations and certifications for security is we're PCI, HIPAA, High Trust, SOC 1, SOC 2, ISO 2000, 27001. And some of our main clients, some of our bigger clients we have is Chewy.com, Barclays. We have a use case for ServerPro later in this presentation, Nextgate to name a few. But a little bit about myself, I'm pre-sales cloud solution architect for Logicworks. I'm an Azure expert certified, but I do have AWS and GCP experience too as well. But I've been doing this about 7 to 8 years. And Azure is my specialty because I'm a Windows guy, but I know Linux too as well. But I'm originally from New Jersey. I live in Texas. Huge sports junkie. I played 3 sports coming up, and that's been some hobbies over the years: baseball, basketball, and football. But that's just a little bit about myself. So let's get into this presentation a little bit. For some that know cloud native solutions, others might not. This is kind of an informal way of just discussing what they are, right? How do we define cloud native computing? Cloud native computing multiply is containerized workloads. It allows you to either package your app into a container or break your app into microservices. To get to cloud native, this is the path that you have to take. Cloud native computing is dynamically orchestrated, so containers are actively scheduled and managed for optimized resource allocation, and are microservices oriented in nature. So I can break out my UI, my web portal, my API, and database into separate containers. And if I was leveraging Kubernetes as my orchestrator, I can have them in separate pods or have multiple pods on an actual host that would have my application. Also, cloud native computing could be serverless too. So if I have an event-driven application, I can run that as a Lambda function, or I can run it as an Azure function too as well to be executed on demand. So some of the business drivers, what's the main business drivers to move to microservices? I get this a lot in the industry. And then I always go back to the main reason why somebody would move to the public cloud to begin with is scalability. Microservices allows you to scale to multiple hosts, it allows you to auto scale, it allows you to self-heal. It's a little bit harder to do that with monolithic applications, especially if they weren't written to do so. So some caveats to that is business critical services will have increased availability and performance in microservices on Kubernetes. You will be deployed on multiple hosts, mitigating single points of failures, and performance degradation you would have like on a single server. Faster time to market for your application, because these are loosely coupled services. It will allow you to add a new service or feature without having to rewrite the whole code base and application, which means you can develop and test and deploy quicker in this model. It's easier to debug and roll back. So any smaller modules that you build out goes through a continuous delivery and testing process, which allows you to deliver error-free applications, and rollback is only for like a single module, not an application. So if I have a bad code release, I have to roll back the application to monolithic, and this is just the module that I can just redeploy. You get an improved ROI while reducing your TCO. So you move away from expensive hosts and machines that would run your application traditionally. You move to more of a AKS or EKS or GKE, wherever you're using in each of the clouds. And that's a reduced cost model. And if there's some storage that's necessary, that's object storage, and that's even cheaper than running on like a SAN or dedicated server infrastructure. You can increase resilience in this model, which means your monolithic app code failures which would affect multiple services, goes away. With microservices, there's minimal impact. So we talked a little bit about that. You could just take one of the services out and put it back in. So there's no service disruption to the user base. So some use cases, talked a little bit about microservices. We'll go into serverless a little bit. Some of the main use cases for serverless is for trigger-based tasks or event-driven apps, but you can also throw RESTful APIs into this model too as well. So essentially, if you had a FTP file that's put to some blob storage repository, right? The trigger would be once the file gets added to the storage, you can execute your code in Lambda or functions to process the file to do something. Whether that something would be move it to a database, take unstructured data, transform it to structured data. You can do this with a serverless task versus having this on an EC2 instance or an Azure VM to run multiple applications to do this task, which is cheaper and more scalable. Also, if you have some async processing tasks, like if you do rendering or transcoding of video files or whatever, you can run these in background in serverless. So that's a good use case. Security scans, if a new user gets added to Azure Active Directory, case in point, the trigger would be once the user's added, the scans the user to see if MFA is enabled for that user. Or if a new container gets put onto a Kubernetes host, make sure container security is enabled for that container. Those are kind of the things that you could do with the security scans capabilities of serverless. And for CI/CD, if a code commit takes place, you can trigger a functionality new application. So that's a nice use case for serverless too as well. And for microservice, the main use cases, really the two big ones I see in the industry is app modernization and refactoring legacy applications, right? A lot of customers want to get out of the data centers, want to move to cloud, necessarily don't want to do a lift and shift, but they want to take advantages of the economy of scale cloud. This is the way to go because on top of the caveat that you get to use the economies of scale, it's portable. So my application, if it's in a containerized workload, I can move it to any of the public clouds. There's no vendor lock-in. I can move it to GCP. I can move it to AWS. I can move it to Azure. It's just redeploying my containers in each of those cloud providers and any kind of database migration that takes place on the back end. There's a bunch of tools that does that, and it's pretty easy to do migration in that manner versus the traditional 500,000 VMs or servers that are going to move into the cloud, and they're going to make sure everything works as intended. So a little bit about containerization, kind of went through it, but essentially know that containerization is just a runtime environment for my application. So it decouples that OS level dependency, right? It allows me to get better visibility in my application, and I can isolate my components. And, containers are ephemeral by nature, right? In the industry, there's a concept for containers. They're called stateful or stateless. You probably heard this before, but I'll kind of go through it as an overview. Stateless containers, essentially, they neither read nor state or store their information about its state. So if I have a web front end, I usually put my session state on Redis cache. I don't have it on the container. I move that off. And any web front end features would probably be on some sort of object storage. So if my container restarts, it knows to go back and get that data from either Redis cache or S3 or Azure Blob Storage. The stateful container essentially has persistent storage because it needs to know its state every time it's ran. So things that are stateful in nature that are containers in the container world is usually databases. So if I had a lightweight MySQL database, I need to have a storage for my database transaction logs, my data files, my cache. So that's a good candidate, or even monolithic apps. So let's just say if I move my Windows app into a container, I have to put my D drive, E drive, F drive, whatever, somewhere on some storage. So that's a candidate for a stateful container. And if you ever wanted to test containers in Azure AWS, they do have capabilities to do that. Azure Container Instance is one of them. It's a single Hyper-V host that you can do Linux or Windows containers. So if I needed to just do a Docker Compose or do an image of my application, I could test it there, see if it runs, how it runs from a performance standpoint, and just tear it down, right? I can also do that in App Service Plans. And in AWS, I can do this with ECS, which is their Elastic Container Storage or service, Elastic Container Service. So microservices essentially is, like we said, loosely coupled small autonomous services. So each service is a separate code base. So a small developer team can write and maintain a service without bringing the whole application down. Services can be deployed independently, so that same team can update an existing service without rebuilding and redeploying the whole application. Services are responsible for persisting their own data or external state, and services can communicate with each other by using well-defined APIs. So basic pod-to-pod communications. And in Kubernetes, what a pod is a container and a container, right? I might have my web front end, I might have my API middle tier, and I have my database in one pod, and it's on one host, and I'm going to communicate to another host. It's usually done through DNS, external ports, or external IP addresses. And so that communication takes place through APIs. It supports polyglot programming, so services don't need to share the same technology stack, libraries, or frameworks. And serverless, I like to say this because it's funny, because I love the term. There's no servers to manage, but there are servers. So essentially, in the serverless world, you don't have to manage an EC2 instance. You don't have to manage an Azure VM. It's usually a Lambda function or an Azure function that's being used. And essentially, in that space, you're charged for code execution and how many executions you do in a month. So you don't really have to pay for CPU, RAM, storage utilization. You're just paying for code execution. There is a concept called pre-warmed instances. I'll go into that a little bit later. But it's scalable. It's dynamically scaled. And in the serverless world, you decrease your latency of code execution because it can be run on demand, or there might be a little bit of delay in running the code. You're not dependent on multiple things on your server that is going to decrease your latency of code execution. And a little bit of a reference architecture here. Essentially, this is what AKS and microservices look in Azure. And when I was talking about the pods, you can kind of see in the middle there. Each of these pods, you can have one pod through a single AKS node, and this could be EKS2 as well in Amazon, or it could be GK in Google, right? You can have multiple pods on a host. You can have one pod per host, and the pods can either be .NET, it could be Node.js, it could be Ubuntu. You can mix and match. It doesn't really matter the stack. Your containers will live in some sort of Azure container registry, or some kind of registry that will have your microservices that are composed or coupled and done through Visual Studio, through DevOps, through a CI/CD pipeline. They'll be placed in this container registry to deployed into these pods. And then there usually is some sort of database as a service offering on top of that. Some customers do lightweight containers for databases. I don't recommend it. I always recommend using the database as service offerings or Amazon RDS to have your database data there, because it dynamically can dynamically add resources for the allocation that happens to the database that needs that performance. And so you can use Azure SQL Database, you can manage instances, Azure Cosmos DB, MySQL. You have the pick of the litter of all the database technologies that you can leverage. And for multi-cloud, this is what I was talking about. You can do with AKS. You can also do this with serverless. Concepts still are the same, right? You're going to have some sort of mobile app or user app that will have a global load balancer, whether that's through a third party, through a Capsula, Cloudflare, or through an API manager. You can route your traffic in a way that you can do a weighted route of 50% of your traffic to AWS or Azure, or you can do an active passive. So if the health check fails, then I have all my traffic go to one cloud. And also I can do latency-based routing with my traffic too, right? So if I have users closer to an Azure region or closer to an AWS region, they go to that region for service of their application. And then you could have this as a serverless kind of architecture. You can do the same thing with AKS or any kind of microservices technology. And you're going to have some sort of trigger that's going to allow you to do an Azure function or a Lambda function for shopping cart orders or inventory, and get notified once those executions take place. And the same for the multiple clouds that you decide to deploy in. So some benefits and challenges. Benefits of microservices, of course, agility, right? It's easier to manage bug fixes and feature releases in this model. You can update the service without redeploying the entire application. You can roll back and update if something goes wrong. It's not detrimental to the environment. You get a smaller code base in this model. So this minimizes dependencies and makes it easier to add new features and functions. You get fault isolation, of course. If a microservice becomes unavailable, it won't cause an outage, again, to the whole application stack. And upstream microservices will need to be designed to handle these faults correctly. So when you build this model out, there's a concept called circuit breaking that you have to build in. So it's not by design, but that's part of that whole refactoring and replatform strategy to go into microservices. And some of the scalabilities, you can get to the auto scale capabilities with this because all the AKS nodes can auto scale and self-heal. You can do data isolation to perform schema updates to your application, and reduction of cost to deploy new apps. So microservices and containers, you don't pay for containers. You have 150 containers, you won't pay for them. What you do have to pay for is the AKS hosts and the storage and the egress charges and anything else you add in there, like a global load balancer and stuff like that. But those are nominal costs. If you were a VMware shop and you had 100 VMs and you deploy 100 VMs in Azure, you pay each one of those VM costs per month. And in this model, I'm just paying for the node costs and some storage, which is some of the cheaper costs in cloud. And some challenges, of course, there's more moving parts with microservices versus the monolithic application model. So even though the services are simpler to deploy, you have more of those application and services. So it gets a little bit more complex. Network congestion and latency is something also that is the thing that you have to take in consideration, because you have these small granular services, which can make the app chatty in nature. So you have to be aware of those congestion and latency issues as more of those microservices you deploy into your AKS or EKS environment. And versioning, right? Without careful design, you might have problems with backward and forward compatibility with your containers. So you have to really be cognizant of that when you add multiple services at any given time. And skill set, right? You need a mature DevOps practice for ultimate success in the Kubernetes world. Some benefits of serverless: lower costs, even more so than microservices. So Lambda and Azure Functions. I'll give an example for Azure Functions because I know those numbers in the back of my head. How cheap is to execute code per month in Azure Functions? Well, the first 400,000 gigabytes per second of execution and 1 million executions are free with Azure Functions per month. So if you're under that model, you don't have to pay for anything. The only thing you probably have to pay for is some egress charges and some other things that might be added on top of that. But essentially, that's not an AKS node cost or any of those other costs that might go along with it. There is another cost called pre-warmed instances. And what that means ultimately is you have an instance there on demand to execute your code. So there is a little bit more of a cost for that model, but it's depending on your application, which one you need. The enhanced scalability you get, of course, you get the auto scale capabilities of serverless. And productivity, you can add code without having to maintain servers. So you don't have to maintain EC2 instances, you don't have to maintain Azure VMs. And some challenges of serverless, of course, there's always challenges. But the one challenge that I always tell customers is vendor lock-in is a thing. It's real and it happens. So if you're familiar with how everything works in AWS for serverless and Azure Lambda, you know that everything works seamlessly and it works, right? You take that same model, move it to Azure, it's not going to work. It's a different concept, a different way of doing things. And Azure Functions, the same thing. Everything works seamlessly on Azure. It's great, but if I move this over to Lambda and AWS, it's not going to work the same. So there's some things to be aware of in the serverless model. And there's a performance impact too. So cold starts are a thing in the serverless environment. So it's basically if I have a Azure function that's idle and it waits every 24 hours to execute a line of code, it's going to be about several seconds of latency before the code execution takes place. And if your application needs to be on demand, that's where those pre-warmed instances come into play. And so essentially when that execution takes place, the pre-warmed instance automatically runs the code. There's no latency and it works. You have to know that when you go into the serverless model. Also in the loss of control within the serverless model, it doesn't happen often, but it does happen. If there is an issue, it's a bad day at AWS or it's a bad day at Azure, and some outages takes place from a server standpoint on the backend servers that run Lambda and functions, there's going to be an outage. You have no control of that. But most of the AWS and Azure features have redundancies built in. So it's something that does not take place often, but just be aware of that. So essentially, we're coming down to the end of this presentation. I'm kind of talk about how Logicworks can help you if you decide to go down this path. We have scalable teams available on a month-to-month basis, so we can help you update your legacy code. We can break apps into microservices. You don't have a CI/CD pipeline. We can build that for you. We can help containerize your application. We can help build serverless workloads where it makes sense. And if anything, if you need any kind of database and analytics that help, that you don't have a DBA in-house or a data architect to help you out, we have those people in place to help scale your databases to go with your microservices and your microservices environment. And essentially, this is basically, in a nutshell, what we can do for AWS and Azure, but this is Azure specific. Application modernization services, we offer those for you. We can do refactoring, we can do replatforming. We leverage all the cloud native tools, so you don't have to have technical debt of all these tools you have to use once we give it to you. Everything is cloud native in nature. And if your DevOps teams are not up to speed, we give you enablement and workshops to help your DevOps team get up to speed for microservices or serverless technologies. And we also can update legacy code base. So there's times that I have gotten Great Plains on 2003, 2008. How do I get into the cloud? There's no image for that, right? So we have to package that as a container and move it to the cloud, especially if I'm doing a data center migration, or if I'm doing just getting it off of my closet or out from underneath my desk or wherever it is, and I got to move it to the cloud. Those are great candidates for containerization. So a real quick case study. ServerPro is one of our main customers, ServerPro. They wanted to migrate their business critical application to AWS, along with their ongoing compliant managed services that they had on VMware. And it was daunting in nature because the app was legacy in nature, and it had 200 apps with dependency to a single database, which supported 1,700 franchises. So that's not an easy migration, and they couldn't take a lot of downtime. So what we did was we designed a Kubernetes K8-based architecture in AWS with Aurora backend, which is their version of MySQL. And we decoupled those app dependencies between the backend apps and the primary apps, which allowed additional apps to be migrated without significant downtime to the user base. So we created an automated CI/CD pipeline and an AMI pipeline governed by CDK in AWS and CloudFormation to basically automatically deploy and migrate those apps along with the other 200 apps with low downtime to the customer and in a faster and more expedient process. Because when we first quoted this out was a year migration, and we got it down to months. So we collaborated with the ServerPro team to create a customized solution and incorporate cutting edge technologies to significantly increase their deployment speeds into AWS.
Shawn, that was great stuff.
Yeah.